All right, let's have a look at some of the revision questions now at the end of the chapter. So chapter 9, revision questions. I'm on page 266. I'm looking at 18 because it's a little bit different. Albert's lost the plot. He's having a nap. He's bored with these simple circuits. Okay, so what have we got? We have got 2 ohm resistor and a 4 ohm resistor. And then we've got this parallel part to the circuit. You don't have to worry about this bit here. That's just the voltmeter that's popped in to measure the voltage drop across this parallel part. And remember that the voltage drop is the same across any part of the parallel part of the circuit. So that's all good. All right, handily, we have one of the currents already. 4 amps has come in this little parallel part here through the 16 ohm resistor, but we don't know the voltage, so we're going to have to find out the total current and total resistance and then use that to find the voltage. So I've got 4 amps going through this 16 ohm resistor here. This other one here is also 16. So that tells me that 4 amps is also going to be going in this part. So 4 amps in this one, 4 amps in this one. They're going to join up again. Over here I've got an 8 ohm resistor. Now I could use Ohm's law and work out, because the voltage drop is the same across these, I could go V equals IR, so 16 times 4, whatever that is, and divide it by 8 to get the current in this bit. Or I could just go, this resistance is half of the size of this resistance, so that means it will get double the amount of current. So if I've got 4 amps going through the 16 ohm resistors, I must have 8 amps going through the 8 ohm resistor. So you don't even have to work anything out. Okay, so these bits that are in these parallel arms were once all together. So the total current in the circuit is going to be 4 plus 4 plus 8, which is 16. So I can quickly draw this up as another little circuit. It's a bit wild today. And that gives me my answer for X, doesn't it? So the current is 4 plus 4 plus 8, 16 amps. And I've got 4 ohms there, and I've got 2 ohms there. And this is the resistance that I'm going to get when I combine those guys. So 1 on R would have been 1 on 8 plus 1 on 16 plus 1 on 16. Oh, we've already answered what the current in Z was and what the current in Y was. So we've only got the only question we have left to answer. Well, they want the battery voltage, and they want the reading on this voltmeter. So that you just V equals IR to get that one. I've got distracted. Hang on, go back to what I was doing. Okay, so what does that give me? That's 2/16. You'll just do it on your calculators, whatever. It's 4/16. Flip them upside down. 16 over 4, so a resistance of 4 ohms. Righto, so this is worth 4. So that means my total resistance is just going to be 2 plus 4 plus 4. $10 ohms. And the total current we worked out before was 16. So V equals IR. We actually want V this time, don't we? Because we want the voltage in the battery. The total current was 16 and the total resistance is 10. So it's 160 volts. Seems a lot for a battery. Must be a pretty good one. What do we need? Oh, we need this one here. And it's going to be just a V equals IR business as well. So the current is 8. The resistance, so it'll be 8 times 8 equals 64 volts. Done.